Before we can create our two inequalities, we have to start by isolating the absolute value. We'll subtract 3 from each side with the absolute value of x is greater than 4. This allows us now to split. Remember, greater than means an or problem because our distance is further away than 4. So we've got x is greater than 4 or x is less than negative 4. Because the positive 4 is changing its sign, the inequality symbol must change as well. So those are the solutions, and when we look at them on the number line, we have a negative 4 and a positive 4. These are both open circles because there's no or equal to, and we want to get further away from 0 than a distance of 4, so we're shading to the outside. That's why we have an or for a two-part problem. The next one, we have to start by isolating the absolute value as well. We're going to start by subtracting 6. So we have 5 times the absolute value of 3x minus 1 is less than negative 3. We're going to divide both sides by 5. So we have the absolute value of 3x minus 1 is less than negative 3/5. Now we want to remember, back when we were solving absolute value equations, if we had something like this, the absolute value of 3x minus 1 is equal to negative 3/5, we immediately said, wait, that's no solution because my distance can't be a negative amount. Well, if my distance can't be a negative amount, it certainly can't be less than a negative amount. So this is a no solution problem, and the graph would be empty. Now, just think about a what if, however. What if we had the absolute value of 3x minus 1 is greater than negative 3/5? Now we're saying the distance from 0 is a positive value, and that is possible. The distance from 0 is greater than negative. My distance is always going to be greater than negative because I'm either going to be right at 0, so my distance would be 0, or I'm going to be a positive distance away from 0. So this would be an all real solutions situation. All real numbers would be my solution. That's not what's going on in this problem, but just to be aware that that is a special case. Next, we don't need to isolate the absolute value in this one. We can go straight to writing the two inequalities. 5x is greater than or equal to 20, or 5x is less than or equal to negative 20. It's saying the distance is further away than 20, so that's an or problem. And when we change the sign on the 20, we also change the inequality symbol. Both of these can be solved by dividing by 5. So x is greater than or equal to 4, or x is less than or equal to negative 4. This is very similar to one of the earlier problems. The difference being we've got or equal to's. So now I'm coloring in these dots before I shade to the outside. Finally, I have another one where I need to isolate the absolute value. So I'm going to divide both sides by negative 2. So I have the absolute value of x plus 5. I'm flipping from that greater than to a less than or equal to positive 3. Now I've got a less than problem, so this is an and rather than an or. I'm going to have to be between. You have two choices about how to set this up. You can use option 1, which is to say x plus 5 is less than or equal to 3, and x plus 5 is greater than or equal to negative 3. That's one option. The other option is actually a little bit easier to get to the final answer, so it's the one I'm going to pursue. Notice we're saying x plus 5 is bigger than negative 3, but also at the same time smaller than x plus 5. So I can actually say x plus 5 is smaller than or equal to 3, but is bigger than or equal to negative 3. I'm sort of sandwiching the x plus 5 between the two numbers. This is my preferred method because it becomes really easy to see how to make the graph. I'm going to get x alone by subtracting 5 from all three sides. I have negative 8 is less than or equal to x, which is less than or equal to negative 2. When I go to make my graph, I can see that x should be between negative 8 and positive 2, and so I know I can shade in between. I would also be able to figure this out the other way if I had the true written out and problem. I would subtract 5 on both of my inequalities. X is less than or equal to negative 2, and X is greater than or equal to negative 8. But I'd have to be really careful when I graph. Students have a tendency to just have their graphs point out. We can't always make that assumption. We'd be like, okay, wait, this one's shading this way, this one's shading that way, so it's in here that they have their solutions in common. So that would lead me to make a graph that looks just like the one that we made on the right.